Okay guys, today we're going to talk about multiplication. How does it happen on the computer? We're going to first talk about one case where if I have the multiplier a power of 2. A power of 2. The other case we're going to talk about Booth algorithm, where if I have 6 multiplied by 7, or where I don't have the multiplier or multiplicand as power of 2. So if I go to this case, multiplication, where I have a power of 2, 5 multiplied by 8. So what's 5? Let's get 5. 5 is 1. This is what? 2 to the power 0. 2 to the power 1. 2 to the power 2. 4 and 1 is 5. So this is 5 in binary. And what's 8? 2 to the power 3. So we do just a regular shift left by 3. If I shift left by 3, move 1, 2, 3. So this one is here, and this is going to be 1, 2, 3. This 0 is here, and 1, 2, 3. This one is here. Now if I say 5 multiplied by 4 is 5 multiplied by 8 is 40. And if I check this, what's this? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, which is 8, 2 to the power 4, 2 to the power 5, which is 32. So 32 plus 8 is 40. It's 40, so this is right. Let's see this multiplication. 3 multiplied by 16. What's 3 in binary? 2 to the power 0, which is 1, 2 to the power 1, which is 2. That's 3 in binary. 16 is 2 to the power 4. So I shift left by 4. So I'm going to move 1, 2, 3, 4. I'm going to put them here. Is it 48? Let's see. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, which is 16, 2 to the power 5, which is 32. So this is 48. This is right. If we're doing division, we shift right. Multiplication, we shifted left. Division, we shift right. Remember, the number is going to be smaller, so it has to shift right if you forget which. So 20 in binary, it's going to be what? 2 to the power 0, 2 to the power 1, 2 to the power 2, which is 4, 2 to the power 3, 2 to the power 4, which is 16. 16 plus 4 is 20. So this is 20 in binary, and I have 2 to the power 2, and I have a division, so I shift right 2 places. So I'm going to move all this here, so I'll have what? 1 and 4, which is 5, and 4 divided by 20 divided by 4 is 5. If I go and try the 48 divided by 8, which equals 6. Let's see the 48 in binary. 0, 1, 2, 3, 4. 2 to the power 4 is 16. 2 to the power 5 is 32. So those two are 48. And I divide by 8, so I shift right 3 places. 1, 2, 3. So I get this. This does it equal 6. 0, 1, 2. This is 2 to the power 1, which is 2. 2 to the power 2, which is 4. So this is 6. This is right. But now what happens if I don't have 2 to the power something? For example, if I have 6 multiplied by 7, can I have it in 2 to the power something? No. So we do Booth's algorithm, and here's the operations on Booth algorithm. You have to memorize those. If I have 0 and 0, what I mean 0, this 0 is Q, and Q minus 1, and this 0 is Q0. And let's see what's Q0. Q0, I'll have the 6 here as my initial value. This is 6. This represents the 6. So this is 2 to the power 0, 2 to the power 1, which is 2, 2 to the power 2. So this is 6. This is Q0. So I'll take this one and Q minus 1. I'll just initialize it to 0 at the beginning, and initialize this to the value of 6 in binary, and initialize the accumulator to 0. So I'll look at those two. I look at this 0, I look at this one and this one, and based q minus 1 and q 0, and based on that I'll decide. If I have 0 and 0, I'll do a right shift. For what? For the accumulator, the q, which is the multiplier, and q minus 1. If I have 0, 1, q minus 1 is 1 and q0 is 0, I'll do add. I'll add the multiplicand, which is the 7 in the previous slide, to the accumulator. We'll see how that happens. If I have 1, 0, I'll subtract the multiplicand, which is 7, from the accumulator. If I have 1, 1, I'll do so 1, 1, 0, 0, I'll do a right shift. Think of it as this is an XOR. On 0, 0, we just do a right shift. This, how I memorize it, is 0, 1, I think of it as positive because I have a 0, so I'll add. 1, 0, I think of it as negative, so I'll subtract. So let's take this example. Now I have the 7 here. How do I represent the 7? 0, 1, 1, 1. This is for the sign. This is 1, 2, and 4. Those add up to 7. So this is 7 in binary, positive 7. If I find the 2's complement for this, and how do I find the 2's complement for this? I'm gonna have 0, 1, 1, 1, and I flip, find the 1's complement. Here's the 1's complement, and then I add 1. So I'm gonna add 1 to this. I'm gonna have 1, 0, 0, 1. This is the 2's complement. This is the 2's complement for the 7. This is 7, meaning negative 7. And I'm gonna show you why we need it. So this is, let's see. Okay, step 1 is not gonna be this. Let's do, okay, sorry, and let's fix it. And I think you need to fix it here, and let's fix it here. I need to fix it here, and this will be S1, S1, and in this first case, what do I have? I have both the multiplier and multiplicand as positive numbers. This is positive 6, positive 7. Here's the 6, Q is the 6. I'll start. Accumulator is 0, 0. I initialize it to 0. Q minus 1 is negative, is 0. I'll initialize it. So first thing, I'll look at what? Q minus 1 and Q 0. If I have 0, 0, what do I do? If you look at this, right shift. I just right shift this whole thing. So let's right shift it. I'll shift this 0 here. So here I'll have oh, okay, sorry guys. So I'm gonna have to go back here. I'll have 0, and here I'm gonna shift this. I'm gonna have 1, 0, 0, 1, 1, and this is gonna be 0, 0, 0, 0. I'm gonna leave it like this so we can do. This is the first step. Why? Because I had a shift right because of 0, 0. And let's put those here, 0, 0, because of those two. Now I look at this. What do I have? I look at those. Does this have a pen here? No. What is this? Looper now. So I'm gonna look at this one. And let's make it a different color. What color should I use here? Dark green. This one. And this one, Q minus 1 and Q 0. I have 1 0. 1 0, what does that apply? 1 0, and I told you, I think of it as negative, so I'll subtract. Subtract what? I'll subtract, and here how it goes. A or AX equals AX minus 7, or let's call it B. So how does the computer do the AX minus 7? Well, it does it adds what? AX plus the 2's complement of the negative 7, which we have here. So I'll add this, the AX, with the, so I'll have the same number. This won't change. And let's make this smaller, so we'll have some more okay, so we have more size for the addition. And if we do any, no, I'll do it on another point. Okay, we'll do it like this. So I'll have this won't change, and this is 0, and this is step 2. Now I did this. Now I'll shift right. I have to shift right. This is step 2, all of it. So we don't have another extra step. So what will I do if I shift this? I'm gonna have here a 1. I shift this here. I shift this. I have 1 0 0 0, and I shifted this here, this here, this here, and I need to take that last 0. It's gonna be a 1. So this one here, and I'll have now 0 0 and 1 and 1. Why? I shifted this, and I shift the sign. This is really important, shifting the sign. I shift this to here, and I shift the sign stays negative. So now I look at those. This. Okay. This one, and let's mark it as green. And this one. What do I have? 1 1. What do we do? 1 1. It's gonna be a shift. Right shift. So here, shift right, because I have a 1 1. So we know the differences. This one step, this is step 3, and I shift right. So I'm gonna get rid of this one. I'm gonna bring this here. I have 1, and here I'll have a 0, then a 0, then a 1, then a 0. Why? I shifted this here, this here, this here, this here, and here I'll have 1 1 0 1. Keep the sign. Keep the sign when we shift. So now what do we have? We have 0 and what? And 1. 0 and 1. I said, well, I look at it as positive. So what will I do? I'll do AX equals AX plus, what was it, plus 7, or plus AX, yeah, plus 7. So I'm gonna add this to 7 to this. So let's see what we'll have, and let's do it here. And if I have 0 1 1 1, is my accumulator, or this is 7. My accumulator is this, and I'd have 0 1 1 1, and this should be what? Let's put an underline under this, make it, this is gonna be addition, and here I'll have 1, and this is gonna be 0. I'm gonna have a overflow of 1 with the third bit, and now I'm gonna have 1 plus 1 plus 1, which is 11. Think of it as 11. Okay, so I'll have another one here, and okay, that's because we're doing it that way. So now this is gonna be also a 10, the last two, or 0 1. Oof. Let's move it here a little bit because I've got the extra bit. Oh, why? Okay, that is awesome. What I need is only those 4 bits, and that's from adding the accumulator to 7. Remember, I need to shift also, so here I'll have, oops, I didn't copy it, I thought I copied it. What did we have? 0 1 0 1 0 1 0 1. This stays as is, 0 1 0 0, and here I'll have a 1, and this is what? Step 4, last step. Why? Because I have 4 bits. 6 and 7 are 4 bits. 4 bits, 3 for the number and 1 for the sign, so I'll have 4 steps. If I had 7 bits, I'll have 7 steps. So let's add a row, insert. I'm gonna insert 2 rows. Why did I insert 2 rows? Why did it come up like that? What's wrong, guys? Come on. Do you see how the rows are weird? So let's do it that way anyway. So now I add it. After I add, I do another shift right. Also we do shift right for this process. So what am I gonna shift now? I'm gonna have this 0 here, and I'm gonna have what? 1 0 1 0. Why did I have that? And let's see here, how much is that size? 36. Okay, let's do this as 36. I'm gonna fix the other table before we go do that. No, come on. So I shifted this, and shift this here, and then here I'll have a 0 0 1 0. This will be, and actually I don't need the last one. I finished now. This should equal what? 42. Let's see if this equals 42. Let's go here and oops, what happened? Is it? Let's redo. Sometimes it doesn't like it. I don't know. The extra row we added, it's gonna be 0 0 1 0 10 10 10. Okay, 10 10 10 should be 48. Let's see. And I'll have 2 zeros. This is what? This is Q, and this is the accumulator. So what's this? This is 2 to the power 0, which is 1, 2, 4, and 8. 1, 2, 4, and 8. So this equals 10 decimal 16 32. 32 and 10 is 42. So we got the right answer. You can check that and see. This is one case where I had this. This is another case where I have the multiple as -6. The 7 is not going to change. This is the 7. This is the two complements of the 7. But now what do I do to the -6? And let's go something goes wrong when you add a row, but anyway, I add it for. So here's the -6. How can I find that? And how do I find the 2's complement? For the 6, what's the 6? 0 1 1 0. Why? This is, think of it that way. This is how I think about it. I have a 1, I have a 2, and 4, and 8. Each bit of those. Saying this is 1, 2, 4, and 8. So those two are 6. 6. And I need to represent the -6. So what do? I find the 1's complement, flip, and I add 1 to the 1's complement. So now I'll have I'll do this, I'll underline it, and oh no, I don't underline this, but I want to color this so you don't think it's, oh, not the background. So now here I'll have 0 0 0 1. No, I'm gonna have 1, and 1 is gonna be 10. So this is 1. So I'm gonna have 10 10. This is -6 in 2's complement. Did I put it in 10? Yeah. So I'll have here -6. Now what do? I look at this and this. I have a 0 0. What do? Shift right. Why? Because I have 0 0. So I'll bring this 0 here. I'll have a 0, and now I'll have what? 0 1 0 1. I'll shift this here, shift this here, shift this here, and shift it. And here I'll have. Now I look at those again. I'll have this as green, this as. So in this case, what do? 1 0. Remember, 1 0 is a negative number. Think of it negative. I do subtraction. So here I'm gonna say AX equals AX minus or minus 7. Sorry. So we'll take, or we'll add the 2's complement of -7 plus this works. So what we'll do is I'll add to the accumulator the 2's complement, which is the -7, and here I'll have 0 1 0 1. Here I'll have a 0, and this is step 2. And now I'll do another shift. After I do a subtraction or addition, I'll do a shift, and this is still all of it is step 2. So here I'll have, okay, I'm gonna have 1 0 1 0. Oh no, sorry. Here I'm gonna have 1, and here I'm gonna have 1 0 1 0. Why I shift this here, shift this here, shift and shift this, and here I'll have 1 1 0 0. Why I shift this here, shift this here, shift this here, and put the sign, keep the sign. And now step 3, what will I do? Step 3, I would look at this and this, and here I'm gonna do an addition. I'll do a x equals a x plus, what do I have here, plus 7, not -7, plus this. So in this case I'm gonna have what, try to put 1 1 1. So I'm gonna have, let's do it here better so you can understand it. Okay, what I need to do is 1 1 0 0. I think that was the accumulator. Yeah, and I add to it 7. So let's see, what will it give me? 1, and I'll have 1 here, and I'll have 10 here, and I have an overflow of 1 for the last one, and this is gonna give me another 10. So I need those two numbers, so I'll have 0 0 1 1. Here I'll have the same number, 1 0 1 0, and here I'll have a 1. And now I'll do another shift. And what, I'll get rid of this. I'll have 0 here. I shifted this one, and now I'll have 0 1 0 1. Shifting this one, 0 0, and sorry, here I have a 1. Why? Because I'm going to shift it from here, and here I'll have 0 0 0 1, shifting this here, that here, and now what do I have? So I'm gonna need I don't know if you need the 6 and 7, but I don't know how another one is gonna fit here. I'm gonna need another. So here's S4. Let's add a row. I need to subtract and do well. No, let me add a row even. No, I have to add a row. Okay, let's see. Well, I don't know why it's acting there. I should have done it as a word, but anyway, let's do now. I look at this and this, so I have a subtraction, then I have a shift, a subtraction, and then a shift. So what am I gonna have here? I'm gonna have ax equals ax minus or plus minus 7. I'm subtracting 7, so I'm gonna add it. So did I get this right? Yep, I shifted here. So now what's plus? Okay, so I'm gonna add 1 0 0 1 plus this, and this is easy. Let's put it 0 1 or 1 0 1 0. I added the 1. It's gonna be 10. Gonna be this, and this will give me this. This is gonna be the same, and this is 0. Now I'm gonna shift this, and I'm not sure why it's not allowing me to add any. If I move it more, okay, that's weird. After, and this is gonna be this, and I'm gonna 36. It's good I added another one, and this is gonna be step 4, so I'm not gonna add any other lines. Why 4? 4 bits. 4 bits. I have 4 bits this. So now look at this, what we're gonna get here. This is the most important part. I'm gonna shift, yeah. Okay. I'm gonna shift right, and I'll have here 1, and I'll have here 0 1 1 0. I shifted this here 1 1 0, and then I'll shift this. I'll have 1 1 0 1. And now this needs to equal what? Control copy. Let's copy here. What do I have? I have here 13, D and 6. D and 6. I like to memorize it in hexadecimal. So let's take this out. D is 1 1 0 1, and 6 is 0 1 1 0. So let's make sure. Yep. Alright. Now what's this answer? What am I doing? I'm multiplying -6 with 7, and this should give us -42. Let's see. What's -42? What's this? Is it -42? How am I gonna know? I'm gonna find the number. So what I'll do is flip. And what am I gonna flip? I'm gonna have this as 0. I'm gonna do the first complement, one's complement. This is 0, and now I have 1 0 0 1, and now this is the one's complement. Now I add 1 to it, and let's mark this as I'm gonna do those. Oh no. This is, remember guys, this is the ones complement of that number we got, and I'm adding 1, so I get the 2's complement. So this is gonna be what? Let's see, what am I gonna get? I should have done it right triangle or on a table, so we don't have to worry about the switching. This is gonna be 0, and this is gonna be an overflow or carry of 1, because I have 10. Now here I have 1, and here I have 0 and 1. Why is that? All of those considered zeros, and here I'll have those as 0 or 0, 1, 0 and 0. Think of it this way, and think of those as here. This 10, 1, I'll have 1, 0, 1, 0, 1. What's this now? I have here what? Remember, 1, 2, so I have a 2, 2 plus 4, 8 plus 8, 16 plus 32, which is what? 42. And if I find the 2's complement for 42, it's gonna give me this number. So my equation is right, our process is right. Here, try to do those two examples. Here, if I have the -7, here I'm gonna use 6. But what happened here? The -7, I'll find the 2's complement of the -7, and then I'll find the 2's complement for that again, which is 7. See this? The 2's complement for the 7 is 1, 0, 0, 1. So now remember, we want the 2's complement for the -7. So -7 is 1, 1. 2's complement goes back to 7 again. This is a really good example. Try to do it 6, and this is gonna give you the 2's complement here at the end. So you have to try to add or flip it. Find the first the 1's complement, add 1, and see the number, and do the same here. This I think will give you the right answer without needing to find the 2's complement. Why? -6 multiplied by -7 is gonna be 42. But remember, here's the -7, which is in 2 complement over 7, and we find the 2's complement for it again, and this is the -6 or 2's complement of the -6. And remember the rules, guys. Remember the rules, and thank you, and see you tomorrow.